as part of building enterprise data warehouse using Hadoop ecosystem. In this video, I will cover more about enterprise data warehouse architecture. And if you remember my previous presentation, the enterprise data warehouse architecture, the current architecture looks like this. There are a bunch of source systems, OLTP, closed mainframes, and external apps, from which we need to integrate data into databases like operational data store and data warehouse, and we have to do the ETL as per our reporting requirements. So, as part of this course, I might not be able to cover closed mainframes and external apps. The most of the exercises and content will be targeting the OLTP, which are traditional RDBMSs like Oracle, MySQL, etc. And I will explain the flow, how it can be implemented in Hadoop ecosystem. As part of this, before going further in the presentation, I just want to go back to the Cloudera virtual machine, which you should have been installed already by this time, and try to explain what is in there with respect to the source systems from which we will integrate data into Hadoop. So now I'm talking about the OLTP portion of it and how it is covered as part of the Cloudera VM. So let me close this window first. And one of the most important directly available icon or tool in Cloudera virtual machine is the terminal. Terminal is nothing but a Linux terminal. So it when you log into PuTTY or any other SSH based tool, you will typically look like this. The background color and all can be different, but when you log into a remote host which is Linux based or Unix based, the terminal will look like this. And the Cloudera virtual machine will come with MySQL database, and the MySQL database is used for many purposes, starting from repository for Cloudera Manager and plenty of other tools in Hadoop ecosystem. So as part of this latest version of Cloudera VM, Cloudera have actually provided the dataset as well, which simulates the OLTP source system. And let me first log into MySQL database. You have to use MySQL command with -u parameter, and you have to give the username which is root, and then -p, which will prompt you for the password. So most of the passwords in Cloudera, if your user account is correct, will be Cloudera itself. So now I can enter the password like Cloudera. So it is like this, Cloudera will be the password, and it will show you prompt like this. And if you are familiar with MySQL, you can run show databases command to list all the databases. In this case, you can see plenty of databases like information schema, which is MySQL data dictionary. CM is probably for Cloudera Manager, etc. So there are Metastore is for Hive Metastore, which you need not worry at this time. The most important thing is retail_db. So this retail_db simulate the OLTP environment from which you can actually pull the data into Hadoop and then run ETL and then port the data back to a reporting database. Okay, so if you have to use a particular database in MySQL, you have to use command. So you can type like this, hit enter, and now you are in the retail DB, and you can actually run show tables command, and it will list all the tables. Okay, so these are all related tables, and Cloudera actually publishes more details about these tables. So what you have to do is you have to search for Cloudera retail DB, and hit enter, and you can click on the first link which says exercise 1 Cloudera, and it will give you the data model. and there is some text as well. So if you think about it, order items is the order items and orders are the transactional tables. Customers will store the customer details, products will store product details, and products are categorized into different categories. So that is categories table, and there is a departments table for a set of categories. So the main transactional tables are order items and orders. So this is a OLTP model which will keep track of orders for a given retail organization, a simple subset of the actual data model. Okay, and now you are able to see those tables in the Cloudera VM. And if you want, you can run some queries like select count of 1 from categories, and it will give you the number of records. Similarly, if you want to see a sample of data, you can run select star from order underscore items limit 10. So it will give you top first 10 records in the MySQL table called order items. Let me run it again. Let me expand this further. Okay, and you can see the header. First one is order item ID, order item ID, order item product ID, order item quantity. So there is only one item ordered in this order, order item total, and the product price. Okay, so this is how the dataset looks like. So we will be using this dataset, and we will try to generate some reports simulating enterprise data warehouse. We will be doing the ETL, we will create the databases. Sorry, let me start from the beginning. We will use this set of tables, and then we will create a few stage databases, ODS, because ODS have a significant role in enterprise data warehouse and enterprise data warehouse database itself. And then we will have we will implement ETL using Hadoop ecosystem, and we will export the already processed data into a reporting database, and from there any BI tool can be connected from to that reporting database and generate reports out of it. So using this data, which is typically implemented using this architecture in conventional systems, we will try to simulate it using Hadoop ecosystem by implementing this architecture. Okay, so before starting it, let us now talk about what is a ODS, what is EDW at very high level, and what type of reports we typically see, and what are the important concepts in enterprise data warehousing. So the purpose of ODS. There are two purposes for ODS. Before getting into ODS, let us see a simple query. Okay, we will run it in MySQL first. So I ran that query already. So yeah, this is the query. What I'm trying to see is I would like to see a number of orders per state for this retail from this retail database. So if I describe, let me run it first. If I describe customers, so I would like to see from the number of orders placed by customers aggregated at state level. So the customers table will have the customer ID, first name, last name, email address, password, and state. So we it has the attribute which we are looking for, and also we are joining with orders. So if you describe orders, you can see the details in orders. Okay, so we would like to see how many orders are placed at each state level for from customers point of view. So how many customers per state have actually placed orders for this retail store. So this is a simple query where I am joining orders and customers, and the join criteria is customer ID, and I am grouping by the customer state, and I am getting the count. It's a very simple query. And this is a very important report. Even this is simple, there are a lot of insights which you can provide to the executive management. So here you can say that you can actually order by as well. If you see, California have 11,000 customers only. Only 11,000 customers from California have placed orders, whereas Puerto Rico have 26,000 customers. And there are a lot of customers which have only 3-digit orders. So if you see this, you can determine what all states the retail store is actually selling products to, and if it want to extend outside those top states to other big states as well, they can focus on whatever states they want to expand their business. So this is even though it sounds a very simple query and very simple report, it will give good insights. Similarly, if you go back to the data model, sometimes we want to see which department is doing better in an organization. To do that, you have to join order items with the products, categories, and two departments, and then you can generate the report. So even using the OLTP database, which actually stores the transactions, you can generate the reports for your executive management to make decisions for the roadmap of the business. But the drawback is joining these four tables in this database. There is only a few hundreds of thousands of orders or order items, and the products table, categories table, and departments tables are very small. So if you join these four tables and try to run a report, it might return very fast. But in a typical large enterprise retail client, you will have millions of orders, hundreds of thousands of products, and hundreds of categories, and tens of departments. And if you try to join all these tables, and then performance might be bad on your core system. For that reason, you have to build an enterprise data warehouse where you can offload the enterprise reporting from your transactional systems, so that reports like performance of departments based upon the orders can be offloaded to a non-transactional mission critical systems. Okay, that's where the significance of enterprise data warehouse comes into picture. Okay, so that is about enterprise data warehouse, but we are talking about operational data store. Then what is the purpose of operational data store? So when you actually develop reports in the enterprise data warehouse, yeah, you are offloading the overhead, performance overhead, to an enterprise data warehouse. And if you implement the same data model in your enterprise data warehouse, even though you are offloading from your mission critical system, if you have hundreds of gigabytes of data to process, using these complex joins, the performance of processing your data cannot meet the SLAs. So for that reason, unlike source systems like this, which uses normalized data model, we typically use a dimensional model. So depending upon the reporting requirement, you have to model your tables. So the table structures will be completely different, which you will understand later. And then you will discard all the unimportant columns, and you will fine tune your data model using dimensional modeling as per your reporting requirement. Okay, so now if you think about it, the source system is following one type of data model, and the target data mart or data model for your reporting requirement is completely different. And also, if you go back to our previous slide here, sometimes for publishing enterprise reporting, there you might have to get data from disparate sources, not just one OLTP. You might have to get data from multiple OLTP databases. You might have to get data from mainframe systems, external applications, and you might have to join all these data sets to build the report. So for all these reasons, the data model in your data warehouse will typically different from the source systems. Okay. That's where you have to master these concepts. This is not a data warehousing class, so I will not get into too many details of data warehousing. You have to master these concepts, and then it will start making more sense. Okay, so just keep in mind that your OLTP systems will follow a normalized data model, and your data warehouse will typically follow a dimensional data model fine-tuned for the reporting purposes, and ETL has to be done between your source systems and data warehouse so that data is fine-tuned for the reporting requirements. So now you might have understood the significance of data warehouse. Then what is the purpose of ODS? Why we are again creating another database? So that's what we are now talking about. So the purpose of ODS is compliance and data lineage. So if you think about organizations like Stock Exchange Commission, if you think about any company which is listed in New York Stock Exchange or any other stock exchange, they have to uh, prepare their financial statements, and they have to retain data for as per the reporting requirements drafted by the monitoring bodies like Securities Exchange Commission. So if you are a retail firm and if it is listed in New York Stock Exchange, and if you have to uh, provide financial statements at the end of the year, when the audit comes, you should be able to support at least for 7 years. So you have to have all the important data somewhere so that you can actually satisfy the audit. Similarly, if you think about the credit bureaus, they have to keep track of seven years of credit history. So that is another example of compliance. So for the compliance purpose, data have to be copied from different sources like OLTP or mainframes or external applications. But there won't be much transformation in the data. So the data model in ODS will be similar to the source systems. So that's where ODS can actually serve your purpose. You can actually have a single source for all the reporting requirements or compliance requirements in one centralized database, and that is called as ODS. That can be ODS. And another use case, there are many of use cases. I am just touching important ones. Another important one is data lineage. So if you go back to this picture, your report might have to be developed from OLTP, mainframe systems, or external applications. Okay, and if you think about transaction systems, let me show you these order items. Describe orders. Yeah, order status. So select star from orders, limit 10. Okay, so if you see this table, there are few orders which are already closed. Okay, and if you think about a typical retail enterprise client, which is pretty big, these closed orders will be deleted through a purge process at regular intervals to contain the size of the tables. Okay, it's standard. Most of the organizations does that. So but your reporting requirements can spawn so let's say your purging requirements is 1 year. Any data which is closed and beyond 1 year has to be deleted at regular intervals, and your reporting requirements are 7 years. In that case, if there is an issue with your report and if you want to troubleshoot the issue, there won't be you will not see the data in your OLTP environment because the data is already deleted, which is closed and beyond 1 year is actually deleted, and your report might need that orders which are closed. So to troubleshoot the issue, the data might not be available on the source. So for that reason, instead of directly copying to data warehouse for that important data will go to ODS first. ODS will follow similar data model as source system with few audit columns, uh, and also they might have the history of all the records. So, for example, let's say an order is placed, which will be an insert, and then order status is updated 10 times, and then order is closed and deleted from the OLTP system. In ODS, in some cases, you might have to track the history. So, if the order is updated 10 times, there should be 10 records in the ODS, so that you can do some point in time reporting, and also for data lineage purposes you might have to keep the history of all the operations on a given order. So for that reason, ODS data model will be slightly different from the source data models, but there won't be very complex transformations. So ODS will serve as a golden source for your enterprise reports. So that is the significance of ODS, and that's what data lineage is. So if you feel that, or if you want to validate your enterprise report, you should be able to fall back on ODS to make sure that the report is generated as per the data without any issues. So that is the purpose of ODS. And typically the data integration to ODS can be real time or batch. If it is real time, people use tools like Oracle's Golden Gate, or Dell acquired a company called Quest. It have a real time replication tool called SharePlex. And also now these days there are some open source real time integration tools as well. Even Informatica have a CDC tool, change data capture tool, which can actually integrate data in real time. In most of the cases, the integration will be batch, and the batch can be daily batch, hourly batch, or um, um, uh, 8 hourly batch, something like that. So data integration to ODS can be real time or batch. ETL, there will be very minimal transformation, as I have explained earlier. There might be few audit columns added to the tables, which will be similar to the source structures. And reporting can be done. So sometimes compliance based reporting will be done directly out of operational data store, and they will not go to enterprise data warehouse for compliance purposes. So now EDW. EDW, again, data can be real time or batch. There will be a lot of ETL that will be done in EDW, and reporting requirements, they can be the real time or batch. So these are the important concepts, enterprise data warehouse important concepts. So there is something called dimensions. So for example, in the previous query which I have ran, if you if you want to submit this report on huge volumes of data in a dimensional model, the customers table can be a dimension, whereas the orders table will be a fact. Means the structures will be different in enterprise data warehouse, but the transactional tables will source the data into fact tables. We will see that little bit over the course, but if you think about it, customer, most of the data is static. Means once the customer is added, his data will be updated only when his address is changed, or email is changed, etc., or password is changed, etc. So that is called as dimension table. So there are three types of dimensions: 1, 2, and 3. You have to explore those things. And facts are the ones which will actually store the transactional data, using which we will be generating the reports. And then there are roll-up tables. So when we say roll-up tables, for example, let's say uh, let's say actually this uh, roll-up tables are yeah, in this case, let's say you want to first see the number of orders placed from each city. Okay, and if you aggregate them you can actually roll up to state, something like that. So that is called as roll up. So instead of doing at state level, now if you run the query like this, c dot customer city, c dot customer customer city, customer state, count of 1, and you can say group by c dot customer city, and I don't want to see all the results. It's fine, I will see all the results. So it is showing 591 rows at each city level, and using this data you can actually roll up to state. So you can actually start, if it is called as granularity, you can start with actual transactional data, which is at lowest granular, and then you can roll up to city, and then you can roll up to state. So those are called roll up tables. You can use the same query to roll up, but in some cases the performance might be bad. So we might want to create multiple tables for each case. So in this case, what we can do is, if you actually uh, run this, I'm doing it from MySQL for now, but uh, after this we will be doing it in Hive as well. Create table customer, sorry, order count by city as. So now the table is created, and you can actually roll up from this table as well. So now you can actually say select customer state comma sum of count from shoot. Okay, now if you copy paste, copy paste, group by customer state, use retail db, and then you can see the results. So this one you can use the same query, but if you think about it, if this table have a few hundreds and thousands of records, then the performance might not be good. So either you can actually start from the lowest granularity and then roll up using the queries, or you can create multiple tables which are already rolled up, and when you connect your BI tool on a particular roll up criteria, if you can make sure that it is actually connecting to appropriate tables, the performance of reports will be much better. Okay, so that is about roll-up tables. Report tables, I'm taking the date dimension as an example, and you can create final report tables, and you can store this data, and you can actually generate the reports out of it. So so all the sorting, aggregations, everything will be taken care before data is being ported into the reporting layer, and from there data will be published to the BI layer. So these are the important concepts which you have to be familiar of when it comes to dealing with enterprise data warehouse. Okay, and as I mentioned to you earlier, as part of the introduction video, as part of this course, we will be applying all these concepts using the Hadoop ecosystem. We will be building a ODS enterprise data warehouse in Hadoop cluster using our Cloudera Quick Start virtual machine, and we will be doing ETL as well, and we will be loading data to the reporting database. And this is how it will work. If we have to integrate data in real time to our ODS or enterprise data warehouse, we might have to use a layer called HBase. HBase uses HDFS as file system, but it is out of the scope of the course, so I will not be focusing much on that. But if you have to integrate data in real time into enterprise data warehouse, typically you will do that in with large dimensional tables. In that case, you have to consider HBase. For batch, we will be using Scoop, Hive, and MapReduce to integrate data. And for ETL, we have to use Hive, Pig, or MapReduce. Again, Pig is out of the scope of the course. For reporting, if it is real-time reporting, you have to use Impala or Presto. Presto and Impala are two alternatives which work in similar manner. Impala is developed by Cloudera. Presto is developed by Facebook. Both are open source. You can use either of them. There is no point in using both. And even HBase can be used for real-time reporting. And for batch, we typically use Hive reporting. We typically use Hive. So that is it for this video. I just want to give a little bit introduction about the OLTP environment and also about ODS Enterprise Data Warehouse and what we will be learning as part of this course. And from next video, you will be actually executing some scripts. You will be understanding Hive architecture. So I will be explaining each dot, and I will make sure that it can be connected in the larger scope of building enterprise data warehouse using Hadoop ecosystem. I hope you are enjoying the series. Catch you in the next video. Thank you. Bye.